This is Yuanjie Shen's proposal videos and it starts. Hello everyone, did you know that the cement production contributes about 6 to 8% of global carbon dioxide emissions? According to the International Energy Agency in 2018, this makes cement one of the single largest industrial sources of greenhouse gases. So concrete is strong, cheap, and essential, right? But its environment cost is really huge. So our research asks a simple but important question: that can concrete incorporating industrial waste material which meets the performance and the environmental criteria for use as a sustainable building material? And earlier, industries produce massive amount of byproducts. For example, the fly ash, slag, silicon fume, and even the baghouse dashes from the industrial filters. Most of these end up in landfills, and if we incorporate it into concrete, this waste could reduce landfill pressure and cut the carbon footprint of the construction materials. So applying circular economy principles in the concrete industry is critical for its future sustainability, like how to change the waste into the sustainable concrete, and our project builds directly on this idea. And past research has shown clear potentials. For example, Mbabi and his team in 2012 report that producing 1 ton of ordinary Portland cement binder emits about 0.8 to 0.9 tons of carbon dioxide emissions. Replying part of this binder is an obvious environmental win. And Nayak and her team in 2022 showed that fly ash concrete not only lower emission but can also improve late age strength. Like that, there are a lot of research, and we search for this and list their advantages and challenges, and also compare to them. Then we find the innovation of our study. This is where our study comes in. Unlike most previous research, which focus on a single material under ideal laboratory conditions, we are testing combinations. For example, baghouse dash with slag and fly ash with slag. These two under realistic environmental stresses. Is that real? Is that real or can achievable? This approach is innovative because it acknowledges that real structure face multiple factors at once. And here is our methodologies and what we are doing. We are prepare several concrete mix. Using local available flash, baghouse dash, and slag combined with Sydney sand and basalt aggregate, sodium hydroxide and sodium silicate will act like alkaline activators. Yeah, we will test mix like 15% slag with 15% baghouse dash and compare them with mix of 15% slag and 15% fly ash. Another set will use 70 to 30 ratios, and then we will run a comprehensive test program. Like for example, they have compressive strength and modular of elastic and water absorption and propulsive test, and all these tests will following the standards, Australian standards, and the shrinkage measure will be test over about 2 months, 33 days. And this test will give us a detailed picture of strength, durability, and environmental performance. And we expect we accept to show that the industrial waste concrete can achieve comparable or even better performance than traditional cement system while being far more sustainable. And as Gomes and highlight in their 2025 paper, optimizing actually activated systems can balance high mechanical performance with long-term durability. If our results confirm this, it could guide and construction industry toward large-scale adoption of waste-based concrete. And this would mean less landfill waste, lower carbon dioxide emission, and a concrete industry better aligned with the needs of a low carbon economy. So, to summarize, our project doesn't just ask whether waste can replace cement. It aims to prove that sustainable material can be both strong and environmentally responsible. If successful, this research could help reshape the future of construction, moving us closer to a world where every building, every bridge, and every road contributes to not not against the fight against climate change like that. Thank you.